Okay, so we are up and running. We are here at How to Build Your SRE Agent. I am Chip Johnson. With me also is Mike Shearer, who is currently labeled as Other Chip by Zoom. But he's really Mike. Um, we are here today to talk to you about our SRE agent harness, which is called Aura. Uh, so let's go ahead and get into it. And there we go. So the first question, of course, is if we are here today to talk about a specialized project for building SRE agents, the natural first question is why? Why don't you just use Claude Code with an MCP server? And the answer is that you need a harness, or we found we needed a harness that was more oriented toward day-to-day operations work rather than software development. Claude Code's a fantastic software development harness. I have it open in the background right now on the computer I'm presenting to you from. I use it every day. Fantastic tool. We have a couple. Oh, Mike, are you handling admits?
Yep, I'll handle admits while you're talking, and then we'll switch over.
Sweet. Um, so the big issues that we run into are around Claude Code doesn't really have a structured schema for setting up a planned workflow. uh, there's kind of an impedance mismatch in the guardrails, right? Like everybody's hit yes, accept, shift tab their way into auto accept mode on Claude and let things run. It's really meant for local machine use and not necessarily for something you daemonize as an agent out in your infrastructure. Like it's really good at making sure it doesn't screw up your Git history, but it'll dump your secrets all day long. It also doesn't emit any events by default, so it's hard to debug it or review the decisions that uh, a standalone development agent makes, whether it's Claude or Cursor. It writes its own trail and leaves out a lot of its internal reasoning dialogue. And it's really eager to ask for human input generally. So we found that if we had it crawling files to correlate an investigation or a lot of other use cases, then it would just sit there and ask us, can I access this? Can I access that? Be throwing perms every day. So we really wanted to build a harness that was custom built, custom purpose for SRE and operations work. And thus Aura was born. Why aren't all right. So let's talk a little bit about agent harnesses. So a harness, again, I have already alluded to this, but Claude Code is itself a harness. It wraps around the anthropic models and makes them suitable for doing software development work. Um, and it excels at this, right? And then Cursor is similar. Um, and they do that by bringing in behavioral tools, right? Structured access to skills, for instance, built-in prompts that can get loaded on the fly depending on what you're doing at the moment. They give you an execution environment. So they give you the sandbox, plugin interfaces, and they have a bunch of opinionated defaults, right? There's all those prompts under the hood to manage memory, context, and really give you just permission sets that all work out of the box. So the idea is that the harness is the control plane around your model so that you don't have to keep rebuilding those pieces from scratch. So I'm going to kick off to Mike now because he was actually there for this to talk about how we actually developed Aura.
Yeah, thanks a lot, Chip. So first off, I'm Mike. I'm not other Chip, but I guess Aura and building this harness for Mezmo has kind of been my work life for a past year. When we started, there weren't a lot of good server side options. As Chip mentioned, like just using a coding agent wasn't quite there. Models are not quite as strong as they were now. So we kind of had this interesting situation. So Mezmo is a telemetry company. We handle logs. We've got some great pipeline products. We figured out a really interesting way to serve a much more targeted context via MCP. And that was all great, but we didn't really have something amazing to run it in. Other than signal from a few customers that it's a very useful addition to Claude Code, but they weren't running it really server side. We really had no choice but to dive head first into how we would tackle and make this work for us. Like as mentioned in the slide there, right? Like one of our first times kind of connecting or a little bit down into here, we found even with filtered logs, we're a company that manages everybody's logs. We have a lot of them. We ended up in this situation where just like a 15-minute span in one of our environments was like 10 million tokens, right? And models at the time were like 200K max ish. So there was a lot of engineering that needed to happen to make that work well. We kind of made some interesting choices around how we tackled this. I definitely don't regret them. It worked out really well. We decided to kind of start in production. And no, that doesn't mean that we just let our first pass at an agent just go wild and do remediations and all this stuff. It was very staged, but everything was like very goal driven from the beginning. So started with what we had, tried to see like how much we could take on, and we had this really interesting development cycle of just charging forward and kind of figuring out, okay, this breaks, even if it's kind of an edge case. We don't want that. Like we're a company that supports a lot of very large companies, important logs. We want to be reliable. So there wasn't really kind of a playbook. A lot of what we found blog wise really didn't apply to our situation. It was very obvious that MCP from the beginning was really initially was really developed to kind of serve your happy little buddy on your machine, which is your coding agent or your chat agent, right? Like there wasn't the right auth considerations or anything for it to really play well in production. So we had to kind of solve all that ourselves. One thing that we kind of found, I alluded to this a little bit earlier, was like fixing edge cases now was a really interesting and like helpful philosophy for us. So like, you can do a lot more cautious product development, right? Whereas that's an edge case, we're not going to hit it as much. Well, the stakes were too high. Edge cases around how to solve saturation from too many logs, how to split tasks up and figure out how to break up this context window, and then just insane amounts of coverage for various area cases, whether it be with the provider. We had a lot of problems with MCP schemas up front, but like really going production first and just head first into it was a really good way until we could get to the point where we were confident that the agent was going to make a good decision. We weren't remediating early on, but like it took a lot to get us to the point where we even trust it to not over query our system to death. So you know, solve your use cases, dive in, remove blockers as they come. It's probably the right way to do it. And, compared to a lot of traditional API development, right, there's a lot of unpredictability with agents. So you just got to do an insane amount of manual testing. It's not something that just writing integration tests solves. So yeah, we kind of trashed through on that and learned a lot very, 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 very quickly without a lot to go off of. Um, let's kick it to next, Chip. Thank you. Yeah, and so when we started getting some signal, we got into this worst situation, right? Like we were actually pretty confident with things, and answers were starting to look right, and we realized this scary thing with AI. Sometimes actually having it fail hard is better than when it gets to the point where the answers start to look right. So we dove into doing for handling these large log volumes. Not only were we doing log reduction techniques and other methods, but we eventually split off into an orchestration framework so that we could say, hey, this worker handles this part of digging into telemetry. This worker handles this other part. So it's more focused. There's kind of like an isolated context window that can't blow up. Everything was looking good, but a colleague of mine kind of pointed out at some point, it's like we were getting these answers that were kind of needle in the haystacks. Like, fine, all these things are broken. If you look at it at a glance, when you started to trust the system, it was interesting because the answers looked very right. But under the surface, we actually started cataloging things from a couple of very specific production events. We were actually having like a large amount of lossiness. Like basically 16% of the findings were gone. What was there looked right. But we had to kind of like re-architect and keep moving forward on edge cases to make sure that we weren't losing data. So as you dive into building your agents, that's just where this relentless testing comes in. You got to get a feel for it. There's there's a lot of these holes you'll get into where things start to look right, and just when you start to trust it is when you need to kind of dive in and look for some edge cases and vetting. So we dove in a little bit further from there. Want to kick next slide there, Chip? This is kind of the design we landed on. Kind of a quick flow chart here, right? Like, coordinator can kind of route and plan. That's where your query goes. That's your main buddy. If you were thinking about it like a Claude Code, this is actually where you're chatting, or in our case, this is where unattended prompts, maybe if something's running in the background, would come through. It's the coordinator's job to go ahead and split up tasks as a DAG and run things really wide. There's just a huge amount of context that can come out of any of these tools or MCPs. For example, like Prometheus MCP or the Kates MCP, even in a trivial environment, a lot of those can produce on a simple call more data than any LLM can handle on its own. So you really have to be splitting things into smaller pieces. Um, this gives kind of a buffer between the main coordinator and the MCP tools. If it overestimates how much a worker can handle, no big deal. You haven't blown out your context window. You haven't killed your worker. It can recover gracefully. Something interesting we did with this whole process that we thought was really missing in the code harness is every step of this fan out and kind of be a DAG and then solve problems that you see here. The LLM actually discloses its intent and the reason why, all the way down to the point of why it called certain arguments. We did that just for debugging because writing, as we found out, writing multi-agent orchestration is actually incredibly hard and really time-consuming testing wise. So we wanted to be able to see at least, hey, single agent, we got a black box here, right? Like you just have to kind of guess or have experience as to why the LLM did something. At least when it's broken up into small pieces, you can see where things are split up. And we realized later that we kind of had created an audit trail for the agents as well. That wasn't the intent, but that's one of the things that kind of came up for it. But you like really need those things when you're not attending an agent. You're not watching it. You're not watching it through a client. You're not reprompting it. You're not able to very easily like cancel things as they come up. So you have to think a little bit more proactive about this. There's also a little bit of tuning that Chip mentioned. Like the tuning is a little bit interesting. So your coding agents are very eager to work with you. This is changing a little bit. They're getting a little bit better at it, but like um, we had to do kind of some specific tuning to get it to at least run a long enough task to bring something back. You kick off something in an incident, and if it's just coming back asking questions every 2 seconds before it's even dug in, it's just not very useful. So we dove into a lot of tuning on that. Next, if you can, Chip. Cool. Yeah, and we will go through a walkthrough. We're going to show how to get things set up, and we're also going to show a real life diagnosis from something that happened to us on the team on live servers as well. I'll hand it over to Chip for right now to get the first part going.
Yeah. So let me switch my share real quick. I'm going to just show you, well, first, of course, is the repository, just github.com/mezmo/aura. You can clone from here. And if you have the correct inbars, right now you can just get it up and running in a very basic mode without any config in it by running Docker Compose up straight from this repo. But that's not how we expect most people will be picking it up. We think most people will want to pick up the straight, well, here we go. We'll want a straight binary. So you can see the projects in Rust. And getting going from the binary is really easy. So we have just a basic Aura init. We'll take you through uh, a quick setup path to write its own basic config. So since I have OpenAI nvars exported already, it detected that. But you can see right now we can do Anthropic, Bedrock, Gemini, fully local if you want to air gap. I noticed we had a question about air gap with OpenClaw in the chat. The question was, have we considered using an air-gapped and self-hosted OpenClaw agent to achieve this? They've seen good results for it with a similar pattern. The answer is yeah, we can absolutely air gap, and you can run this either as a local, or you can run it as uh, or you can run it against a remote model wherever it's hosting. The why not OpenClaw is similar to the question of why not Claude Code. Again, you really want that full decision traceability when you've got something sitting in your ops environment that's making choices. You're going to want to be able to audit every single choice it's made and why it made those choices. Um, so there's just some things that are one of those. Oh yeah, sorry. Other chip answered already. So I'm going to run with OpenAI here and just let it pick up my nvar. Do I want to use my nvar? Yes, I do. Um, and then it's going to suggest for my orchestrator, the main coordinator that we use GPT-5.5, although it can pick up any of those 100 odd models there. And I'm just going to cat my config file here and show you a little, or sorry, let's run through this a little bit. So this is our out of the box config file here. By default, it's going to set you up an orchestrator and a couple of workers. The orchestrator has a very basic prompt out of the box and then tells you which workers we have. By default, we have the incident responder. Its job is triage. It'll fetch alerts, check on calls, handle escalation. The metrics analyst is going to go through various alerts you might have hooked up via those MCPs, and the log analyst's job, again, similarly, is to go through your log analysis, look for error patterns, correlate events, that kind of thing. It also is going to pop up and say that if any of your worker configs don't have any MCP tools yet, we should tell them that the worker can't do any live query, but it can still be useful for offering you general advice. But really, this is designed to be used with tools and hooking up into whatever you already have in your environment. So we've got the basic routing guidance, uh, how it should handle parallelism, delegation, and the red, green, yellow when responding back to users. Um, so I'm gonna scroll down a little bit more. Then we get down to our basic setup is OpenAI with GPT-5.5. Default context window. The Scratchpad is an internal communication tool for the different agents to be speaking with each other and passing information back and forth. This out of the box doesn't have any MCPs. We've got a few things we might set up. And then moving down, we're in orchestration mode, number of planning cycles. And really, I want to get down into here's the incident responder. Again, it has its own context here. Also, we don't have it set, but your log reader might not need GPT-5.5. If we were on an Anthropic setup, maybe you want to have your log reader running on Haiku so it can be faster and using less tokens, right? You aren't going to necessarily need the latest frontier model for each worker. And you can go ahead and start tuning those for use and for cost optimization. We also have a couple of workers that are commented out by default. We have the ops engineer. Uh, the ops engineers, the idea of the ops engineer is that it is the worker that knows how to operate the software that's actually being supported by this infrastructure. So if there are tools inside of your bespoke tooling for upping, downing, restarting clusters, hupping, that sort of thing that might be bespoke, the orchestration worker, or I'm sorry, the ops engineer worker, the idea is his job is to take care of that. And we also have the idea of the runbook engineer who can talk to your runbook store and pull runbook scenarios and also write new ones if we have a update to an existing scenario that we need to push out for use next time, or if there is a totally new scenario that we ran into that we've never seen before, we can automatically amend the runbook set. So they aren't created by default, but we do leave them scaffolded so that people can figure out what to do by example. And of course, you can build whatever workers you want, depending on how you want them to go. So that's the init process, very simple. And then you can kick off in very familiar chat mode with just a local one running on your laptop, or you can decide to run it as a standalone web server. And I'm going to pass off to Mike here to continue the demo.
Thanks, Chip. Yeah, so I'm going to go ahead and pull a couple things up. Chip mentioned a couple different modes of running this. I'm running the CLI detached right now. So I've got a local server set up. It's actually connected to one of our real environments. We're going to do some real-time diagnosis. Wish me luck with the demo gods, etc. But let's take a look at what it looks like to fire this up. Give me a second here. Let's share the screen. All right. Feel free to give some feedback if you're if you're not able to see the font size. I think it should be pretty good though. Okay, great. So on your left, we have a more fleshed out config. This is not terribly far off from the defaults that what Chip was mentioning there from the Bootstrap, but this has our own provider. This has a little more opinionated um, setup with the orchestration itself, and this has full MCP and everything. Like I said, this is going to a real environment here. So this is running on a machine. Logs are on the left. On the right-hand side, we'll go ahead and kick off the CLI so you can take a look at what it looks like. Nothing too unexpected if you've used any sort of like chat-based agent. So what we're going to do here is we're actually going to take an excerpt from a real incident. And it's kind of funny in the dev process here, right? Like we have Aura and we spend so much time thinking about and developing Aura, sometimes we forget that we can use it. And there's this particular thing that happened with me and one of our head SREs as we were going through things, and it was a failure on Aura in one of our environments, right? So we spent about an hour debugging it. It wasn't a big deal. We fixed it and everything. But later I was kind of thinking, it's like, well, why didn't we just use Aura to debug that and dog food it? And sometimes I forget it's there, right? So let's take a look and let's do some really sloppy debugging and see how it goes. So let's go ahead and share another screen here. All right, so we're actually going to take this whole thing and we're going to actually just sloppy paste the whole conversation out of chat. We're not even going to give the agent, you know, much of an idea as to any additional context on this, and let's see how it does. Let's go
Yeah.
back to my shell. Zoom in a little bit. All right, let's see. We're going to go ahead and paste that in. And we're gonna not use an LLM the way you should. We're not gonna be super specific. We're not gonna help it out a lot. We're gonna let it figure it out. Now, this is actually hitting one of our reasonably loaded up environments. It's actually not our live like customer environment, but it's actually loaded down a little bit more in some ways. So it ends up being a great test for us. There's a lot of experimental stuff that happens there, or things that are, still being developed right. So they got more errors or more flood. So it's an interesting environment to develop against. But for the most part, infrastructure wise, not too much different than what we'd run in a more interesting environment. Got lucky today because it's actually going pretty quick. But yeah, we essentially kind of pasted in a bug. Essentially, what we had happen is a downstream timeout was from an MCP, or it wasn't handling it well. It's kind of interesting. So we pasted in pieces from both of the logs on that, and we actually get a complete diagnosis that, based on the logs that are there, because it's just essentially tracing some of our Rust logs and whatnot. It's even providing remediation in code as to like how we might figure out how to overlap these timeouts, etc. So yeah, it doesn't always work out this way. It's generally pretty good at finding things, but that was kind of an interesting one given that we spent an hour on this internally, right? And we saw how fast that came back. That's running Bedrock Sonnet 4.6 under hood, so it's not running a dumb model or anything, but it's also not running anything top tier. And the results are pretty interesting. Um, but as we go, we just keep trying to load it more and more. It's handling bigger and bigger problems all the time. It's kind of crazy because to think about this development process, 9 months ago, a vague query like that, there's no way we would have been able to handle it context wise. That would have just been cascading worker failures trying to do something and the agent coming back saying it can't help you. So a lot of engineering goes into making sure that we can handle those big things, and we'll keep pushing to handle bigger things after that.
All right. Man, we buffered in a bunch of time in case the LLM was slow here, so we might have some extra question time at the end. Uh, are we planning to support a Slack interface? That's actually a great. Let's pause and talk about that real quick.
Yeah, so that's actually our next release. So not a direct Slack interface, but let me back up a little bit. But what we just released, we've had some ways of trying to do this internally for a while, but we released, what we're getting to release is a public human in the loop integration. This supports arbitrary webhooks. So like we don't have a Slack integration. We have internally a Slack integration, but we don't have a public Slack plugin for that. That's not off the table that it won't come out at some point. But yeah, we're actually dog fooding that internally right now. So the way that works, and I'll actually, that'd be interesting. I'll show you the config because we have that set up here. It's a good time to show it off.
Yeah,
Yeah.
and by just released, we mean like yesterday.
Yeah, we just started testing the final version yesterday. It's not the PR submitted and everything, right? There's a little bit of work to follow that up, but it'll be in public here pretty soon. Give me a second to find that part of the config. All right, let me share. There we go. All right. So you can arbitrarily configure human in the loop. This allows us to say, hey, here's your destructive tools, right? In our case, we set up for this demo some specific log tools that could get called that are actually heavy enough. You want to be a little bit careful about how much you're pulling, especially in one of our test environments, right? Like limited bandwidth on some of that stuff. It supports both conversational as well as webhook. What you saw here, we were running it in conversational mode. So if it would have run into one of those tools specifically, it would have popped up a little dialogue in the CLI asking you if you can go forward. The way this runs and the way we're running it internally right now is that it calls a webhook. So if it hits these very specific tools that the agent is gated on, the agent actually can't execute those tools at all. It's deferred to the webhook. You respond to the webhook with either what you would expect from coding agent, right? Like approval, denial, or denial with reason. And that gets folded back into the agent's decisions. But it's sandboxed out. It legitimately can't run these tools without approval. And we support both modes on that. Um, right now, it's just our schema that we posted for how that webhook works. We'll figure out what we want to do for integrations in the future. But internally, we have an internal app that translates this right now to being able to run this in Slack. So these things are posting in Slack right now, and we got a poor logging agent that I let sit there that as a demo, right, and it's spinning and finding stuff all day, and I just leave it to die. I never approve any of them, but it's been a fun exercise to watch it run. Um, so yeah, that's new as of this week, and we have a little bit more fun stuff planned here soon for other use cases for production notifications and being able to have a little bit more confidence in your agent running essentially headless. Uh, you're not monitoring, your fingers aren't on the chat. There's a lot more that has to go into making sure that we feel comfortable running that, especially when you tie remediations into the equation.
Cool. Well, jump back on my deck rails real quick. So here we are kind of talking through the walkthrough, clone it, uh, build it. We are working on the binary distribution right now, but currently need to clone it and build it or just Docker compose up. We do have the Docker images done, uh, but should be quick to go. Well, we're done with demo. So again, kind of the core capabilities we're working into Aura um, are, investigation, root cause analysis, and diagnosis. We want to be able to talk to anything you've got, always share its reasoning, always give you its findings, and any decision it made. Uh, and then, of course, being able to work on remediation is terrifying. You don't want to do remediation out of the box the first time with one of these tools, obviously. Uh, that would be a lot of trust to put in something in a production environment that your livelihood depends on. But over time, as it becomes more and more reliable in the probabilistic system, you want it to be able to start handling things once you know that it's probably going to do the right thing, right? I mean, maybe you don't. Some people do. So you'll be able to make those decisions. And then we want to move into prevention and hardening use cases, cost optimization, change validation. The idea is that since these tools are inherently capable of being self-improving by building better context, then we want to build better context and feed it back. And moving down, as we're building forward, we're kind of committed to four guiding principles for how this thing gets worked out. So each meaningful finding needs to improve the next one, right? I talked already about self-improving as a product. We want it to continue to be self-improving. It needs to be open. We are Apache 2 licensed. We are staying open source. We are open source. If you want to take this and build some competition, that would be sweet. I am in the business of making a de facto standard, not of like trying to uh, do a commercial bait and switch. Um, we absolutely want this to be a completely free product for anyone to pick up, and all the pieces you need to be successful will be in the kit. I need it to be composable, uh, right? The tool stack you already have, everybody's already got Slack and monitoring and a whole toolkit they've put together. And you don't need to adopt a whole new toolkit in order to use this. It should be something that can plug into whatever you've got today. Right now, that interface is MCP, but as new interfaces emerge, new standards come out, you should be able to hook this up to whatever you're using. And then finally, progressive trust, right? Out of the box, I don't expect you to trust an LLM with production work. I expect you to ask it to look at things and give you ideas, and be kind of a sidecar for you, and something that you can use uh, as an advisor at first, and then over time maybe hand it lower consequence decisions. Um, and as it becomes more trustworthy, you can tune the kind of oversight you have. So these are sort of the things that guide what we decide to put in the product, and how we'll build them. Um, Anything that doesn't align with this will probably be closed unmerged. Um, and that is just some oversight about how we're thinking about this and how we're building community going forward. So that's kind of our wrap up. We can get into Q&A. If you want to try it, it's up on GitHub today. We have a community Slack, QR codes right there. And we are looking to build this together in the open. And I want to hear about new use cases, new things people are doing with it. And yeah, I hope you'll join us. And I hope you'll give it a try in your own environments and tell us what you find. So I think, as I said, we put in a little bit of extra padding. Uh, can I use it with the light LLM endpoint? I don't know, actually. Mike, do you know?
Yeah, I guess it depends on the use case. I would assume you could probably, I would assume that, let me make sure I'm reading this right. Yeah, I don't know the answer to that one off the top of my head. I might be conflating with a different product. Um, I'm thinking of a particular like router and interface over the top, which should play fine because we support OpenAI standard as a default if you want it. If we're talking about something else, then I'm off base.
Uh, but absolutely, I would love an issue requesting light LLM support. Um, if you find that it's something we need to add, I absolutely want to add it for you. Oh man, I just noticed our generated AI art, his fingers going right through the screen. That's funny. Um,